There you go. So, as Morton said, hello everyone, my name is Holden, and in my presentation today I'm going to be talking about making games in APL using the new raylibAPL library. So, as Morton already said, my name is Holden Hoover. I'm now a first-year university student at the University of Waterloo studying computer engineering, no longer a high school student. And I have been using APL since 2020 in many different capacities. First time I officially used APL was in the summer of 2021 when I worked on Bob Bernicki's Apex APL compiler, implementing a Julia backend. And last year I was the 2024 APL Grand Prize winner, as Morton mentioned. And I presented my work last year in Glasgow, Scotland on the Radar Ingest System, which was airplane tracking, which is a really cool project and something I really enjoyed. I also have many other various small projects done in APL, all available on my GitHub. Morton mentioned earlier that I had a CLI for Tatin, and I created that script for the project that I will mention on the next slide, which is this summer's project. And I created it because I needed to convince Brian to use Tatin. Or not Brian Becker, Brian Ellensgaard. Yeah, should mention that. So yeah, this summer I worked with Dyalog to create some games, and this is what the presentation will be on. So an overview of the presentation. I already covered who I am. Did that just get dimmer? Yes. So yeah, you know who I am now. I'm going to introduce my project. I'm going to introduce what raylibAPL is. And then I'm going to talk about the getting started with raylibAPL and how I started with 2D. And then I'm going to talk about the actual game, ArrayLab, which is what I called it. And then we're going to go the 3D game making process, APL edition, and talk about some of the challenges in making 3D games and just games in general in APL. And then hopefully we'll sum it all up in a nice little conclusion. So what is this year's project? This year's project started with testing raylibAPL. That was one of the main things. I worked with Dyalog to test out raylibAPL and make some games. So the testing out raylibAPL was actually done mostly through making the actual games. So once bugs were discovered or I needed changes, I worked closely with Brian E. from the Faroe Islands, not Brian Becker here, on many late night virtual meetings to sort through everything. Many emails to support@dyalog.com were made, and Vince is a wonderful person who always replies. So I did some testing, but I also worked on making an actual game in APL. Now, game making is a little bit of a lengthy process. It's the intersection of art and programming, I'd say. So first you need to plan the game. How is it played? What are the mechanics? What is the premise or the plot of the game? And then you need to take off your programming hat completely and put on a bit of an artistic hat. And making good art is not everybody's piece of cake. So of course, many game makers, many game studios outsource their art to other artists, people who are actually good at making art. I can tell you, I am not an artist, definitely. So in my case, I designed some of it, and I designed the models, but I outsourced many of the textures to freely available textures online. So once you have your artwork done, or at least somewhat figured out, you can start work on the actual coding of the game making. For most game platforms, they're like Unity or languages like C++, C#. There are loads of libraries available to use for making games because there are loads of games made in them. For APL, there aren't a whole lot of 3D games made in APL that I can think of off the top of my head. The only one being Stormwind Simulator. And that's the only one I can think of. So for most games, you need some sort of physics engine or module to calculate the collisions between models. And this is a major mechanic in many games, physics, collisions. You also usually need some sort of loading system to load all of the 3D models into your game. Maybe a menu system or a GUI system, maybe a dialogue system so that you can interact with the player can interact with the game. Lots of different components make up a single game. So for anything that I didn't have, because that was most of the stuff, I could program it in APL. So with my project this year, everything is fairly modular, such as the physics module. This is useful as it could be separated into a library that could then be used in other projects, other games, to calculate collisions between two objects. So I have mentioned raylibAPL quite a bit so far. What is raylibAPL, and why would I want one? Well, first let's start with, what is raylib? Raylib is a bare-bones C library for 2D or 3D graphics, input audio, and more. That's taken directly from the GitHub page. I should mention that it can be used for things other than video games, though. raylibAPL provides the bindings for raylib in APL, hence the name, and it uses the quad-NA system function for that functionality. Quad-NA lets the APL application call an external shared library, which allows us to communicate with raylib. raylibAPL is also available in the Tatin package format, and it's very easy to install. That was one of the things that I decided to do this summer because I really like the Tatin format, and I don't like having to go download C libraries and build shared objects externally and trying to import them into my workspace. It's just, I like one thing. So raylibAPL was written by Brian Ellensgaard from the Faroe Islands and funded by Dyalog. Brian's presentation last year goes over a lot of the how it works, but it has changed since then. It's now more dynamic. If I remember correctly, the way he did it last year, it was all statically written and manually he had to create the quad-NA expressions manually. And now everything is done dynamically and loaded dynamically, such that now anytime a new raylib release comes out, there is very little modification that he actually needs to do to raylibAPL before he can then allow that version of raylib to be used with raylibAPL. For our purposes, raylibAPL is a library that provides all of the required, note it is very bare bones, so all of the required components to build a game. And then here is taken from raylibAPL, the GitHub. You can see it has a lot of features. It supports all of the platforms that Dyalog supports. It supports lots of input methods. Touchscreen is an interesting one. I haven't gotten a chance to explore that yet because I don't know of many APL platforms that are supported that would have a touchscreen other than maybe a touchscreen laptop. Then it supports 2D, 3D graphics, and then it also has sound, which is something that I did explore, making some music for the game. It supports text, vector graphics, images, textures, all that stuff. Shaders is one thing that we worked on a lot this summer, trying to get shaders to work because that involves pointers, and I'll talk a little bit more about that later. And then fonts are something that we're still working on getting properly supported. Then texture formats, those are all supported. So yeah, we have lots of different things supported. A big one that I'll talk about later is VR, because I found that one very interesting. But yeah, there's lots of things supported. So getting started, I started with a bit of a standard 2D game. And that's sort of like a de facto starter game. When you first want to try to make a game, you want to try to do something that everybody else has done so you can kind of compare yourself. So I started with a game called FlappyBird. The premise of the game is that you are a bird, and you need to flap your wings in just the right way so that you don't hit the poles and die. And the poles are of varying height and have varying gaps. It's fairly simple, but I think it nicely demonstrates the capability of this game library. It took around 6 hours. It was something like 6 p.m. to 5 a.m. because I was still on my high school graduation sleep schedule. And I'm going to just do a quick demo. Note that I haven't touched this code since I first finished it back in July. And I should mention as well that while making this game, I had a little bit of fun packaging it. I managed to create a Linux app image and a windows.exe file standalone, so it included the Dyalog runtime with it, and then such that it could be run on anybody's computer even if they didn't have Dyalog installed right away. So in theory, I should be able to do a very easy live demo because those work great always, right? Okay, so if I launch FlappyBird, here it is. We've got FlappyBird, and then, oh, it does have sound. And you can see it takes the input from my space bar, and then you can go through these polls and go on. and then you have a high score, and I'm just that good that I have a high score of 2, because I always lose interest after that. And then when you're done with the game, you can just exit and go away. Let me move this back over. So that is the FlappyBird game that I made. And the game does also get more difficult as you progress. So that was a pretty simple game to make. That was 2D, fairly easy to implement. Now we're going to move on to 3D. So as I said earlier, the project was to create a 3D game. So that's what I attempted to do. So the premise of the game was this. You are a person who works at a company called ArrayLab. You arrive to work and suddenly find yourself locked in a room. And the company's AI assistant tells you that the company's mainframe computer has been set to Quad IO 0.5. And you need to set it back to the proper value. Note, I don't say what that is. And stop whoever messed it up from doing it again. And you do all of this while learning APL and doing mini APL challenges to proceed to each level or room. So that was the idea. And the reality was, however, raylibAPL just needed a slight bit more work to get it to work. And this is where the testing came into play. And I'll talk more about some of the changes and the bugs that were discovered. But in short, there were some bugs discovered, both with Dyalog Interpreter. Me and Brian were both doing a lot of work with Dyalog 20.0. We were playing around with the new 20.0 features in this stuff and with raylibAPL itself. And then we were also playing around with some of the Tata features that were coming out. We were trying to integrate it, and I was trying to, I had to make the Tata CLI because Brian doesn't use the Dyalog IDE. He only uses CLI, so it was there was a lot of back and forth of getting stuff to work. So I did spend a lot of time testing and tracing bugs. So instead of making the full game idea, I implemented many different modules. I implemented a model loading system and a physics engine, mostly for collisions. And I started work on a dialogue system for the player to interact with the game. So I'm going to now demonstrate the current progress of the game and sort of demonstrate a lot of the raylibAPL features. And in theory, that should work just as well as the previous demo. OK, I go start. And it takes a little while to load up. OK, I got to move it over here. That's not supposed to be white. Maybe that was a bad decision to try to do a live demo. I'll try again. One more time. OK. I'm just going to quit that, try again. Maybe I can try it with a single screen, yeah. If I go duplicate, and I go start. There we go. So now you can see we're in the game. We're in the room here. You can see we have I wanted this to be Ken's blackboard that I know they have in the UK at the Dyalog offices, though it doesn't have anything on it yet. And over here we have a desk, of course, with the classic Dyalog duck on it there in Dyalog colors, and a bulletin board full of blank notes. And then over here, we have the Quad Quote Labs APL time-sharing network. I don't know if anybody is familiar with the IPSA time-sharing network, but this is sort of similar, I think, perhaps. Yeah, I wonder if there was some Photoshop involved there. So this is sort of the progress, and then the player can jump, the player can collide with the models. Here, the player can try to run into the wall and will not fall out of the level. That's a lot of the physics, hits the ceiling, stuff like that. You see there's a red bounding box around the player. The player is modeled as a box, a very boxy figure. And then when you're done, you press that, you press escape, you get this pause menu. In theory, you could have a bunch of different things. This is a feature called raygui, which is, in raylib, we have a GUI functionality, so you can make an entire GUI app using raylib, just using these sorts of features. It's very easy to implement. And then you just press exit to desktop, and it quits. So now I'm going to go back to extend, and everything's going to break. No, there we go. All right, so that was ArrayLab. That was a lot of the progress. The physics engine I had to write, I rewrote it about 4 times, trying to get it to work the way I wanted it to. Because sometimes, with my physics engine, it wasn't detecting the collisions, and other times it was. And I'll talk a little bit more about that later. So I'm going to talk about my 3D game process in APL and some of the challenges that I had with it. So as I said, the first step is you plan it. So I planned this game. You need to know how it works, how it will come together, what pieces you need. So that's what I started with. And then I made the art. And the next 3 things are where the bulk of the work was. And that's the loading of the art. You saw at the beginning how there was a blue loading screen with a bar. That took a lot of time to get to work properly. Physics, as I mentioned, that was a very difficult one where I had to rewrite it a couple of times to get it to work right. And then a big one was I/O and getting the player interactions and the game's interaction with the player just right. So looking at loading can be a bit of a difficult task. Generally, when you're interacting with the GPU, you want to be on the primary thread. And with APL, I believe the interpreter runs on the primary thread. So when I was loading big models, the interpreter would hang. And so would the game itself. And I believe that has to do with how quad NA works. So instead what I did is I split up the task. I split up multiple large models into multiple smaller models and loaded them instead. This way, every time I finished loading a small model, I could update the window so that Windows wouldn't think that it was not responding. Because at first, when I was loading one giant model, Windows would tell me, your game isn't responding. I'm going to quit it because it's bad. And I said, don't quit it. I promise it's working. So it still isn't ideal because it is still hanging for a certain period of time. And you can only, huh?
You're running Windows.
Yeah, unfortunately right now. My Linux partition got a bit corrupted. So yeah, I split up the task. And it isn't ideal because the window does still hang at certain points. So we were looking into ways to somehow load the models into memory first and then into the GPU to try to reduce the hanging or something along those lines. But neither me nor Brian could figure out a way to do this in any reasonable amount of time. The primary thread issue also causes some other issues. In an ideal world, only processes that needed to interact with the GPU would run on the primary thread, and the rest would run on a secondary thread. I should mention that these aren't like the APL spawn threads, the green threads that Morten talked about earlier, I believe, but they are actual OS threads. Another thing that we ran into at the start was macOS compatibility. For some reason, the interpreter was crashing whenever raylib was run on a Mac. This was happening way back when Brian did his presentation last year on raylibAPL. He couldn't figure it out. So together, I said, let's figure this out. We got out a Mac, and we started debugging on the Mac. And we figured out that it was due to HTML renderer being dedicated the primary thread on Mac, and the interpreter running on a secondary thread. And as such, raylibAPL was trying to start a window and interact with the GPU from a secondary thread, and macOS did not like that, and so it killed it, because it deemed that that was unsafe. So our current workaround to running raylibAPL on Mac is to disable the HTML renderer. At least then raylibAPL does run. But I believe, if I remember correctly, when I was talking to Vince, he said that there is some work going into separating HTML renderer from the interpreter entirely in 21.0. So he said, you know, there probably will be some sort of, however they do it for HTML renderer, we might, Morten, did you want to talk?
No, it's a general problem that these GUI frameworks
Yeah.
tend to want to run on the primary thread. They can't all do it.
Exactly. Yeah, so you can only kind of choose one.
Yeah.
Yeah.
communicate with it.
Yeah, exactly. So that might be how we need to look into using doing raylibAPL. I'm not sure. Me and Brian couldn't figure it out, in the short time that we had in the summer. So we just said, put it off until another day. It's not super important to have HTML renderer and raylibAPL running in the same APL application right now. So another thing was physics. When it comes to physics, we need to know where an object is, and then you need to calculate if they're colliding. And finally, once you know they are colliding, what do you do about it? So to know where an object is, raylib has a very easy way to get a bounding box around a model. I showed that earlier when I had the red box around the player. That was a bounding box around the player. But note that it is a box. So my physics model only calculates collision between what are essentially boxes. So if you have a sphere or any other shape that's not a box, my physics engine essentially approximates that to a box. So earlier when you saw I was trying to run into the desk, I modeled that entire desk as a box, so you wouldn't be able to get into all the different corners and crevices of the desk. So that was a bit of a shortcoming of my current physics implementation. So once you know where the object is using the box, then you need to check if the two boxes are colliding. And it was very difficult to get this part right, because sometimes I had simple planes with no actual volume, and that can be difficult to calculate the overlap. I'm no physicist, so that's why it's difficult for me, but it might be easier for some others who have a lot of experience with physics. So at first, I calculated collisions using volume overlap, but this obviously isn't going to work if you have a 2D plane because they have 0 volume. So then I decided to calculate if their coordinates were overlapping, which I think worked. There are still some issues, and sometimes I randomly fall out of the room, and I believe that's what that initial white screen was that you saw earlier. So after we know that the two boxes are colliding, we need to know what to do about it. How do we move them such that they are no longer colliding? So how do we implementing what I did is I implemented sliding along a wall such that the player's motion would be canceled in the direction of the wall. So my model is heavily simplified, but essentially, yeah, I just cancel out the vector of motion in the direction that is being collided with, which is sort of, that's the maximum amount of physics that I can do right now. And then we also need to take gravity into account with all of this. As long as the collisions model works properly, there should be no issues with gravity. Of course, we don't want the player falling through the floor, so the collisions need to be calculated properly and very well. And this was an issue I ran into for a very long time. Before I realized that my volume calculation wasn't going to work for the 2D planes, every time I implemented gravity, the player would always just fall through the floor forever and ever and ever. And still, there is still some problem with falling through the floor. And that's something that I need to kind of look into. And another issue that I ran into with this physics engine is once I tried to create a level with over 1,000 models. So that's a lot of models, and every frame the engine needed to calculate the collisions between the player and all of these models and calculate what to do about it. And this caused a significant frame drop and was difficult to remedy, so in the end I just decided not to use that level. So that was a bit of a challenge. In the future, what I hope to do with the physics engine is to write it all, rewrite it all again. And I did think about initially looking at maybe using something like an external physics engine that was already written in C or C++ or something else and then integrating it into APL. But I thought APL seems already perfect for doing physics. Why not do it in APL? So that's what, in the future, I will probably rewrite that physics engine. And then I/O is the last main issue that I ran into here. Which was I wanted to display APL expressions on the screen for the player to interact with, and that uses Unicode symbols. The issue was raylib needed pointers to the integer representation of the Unicode string. And instead, what raylibAPL was providing was the integers directly. And this was a bit of a difficult issue, and I went back and forth with Brian a lot on this. He did fix the issue a couple of weeks ago. But yeah, we had a lot of long discussions trying to figure out what the best way would be to fix it. because of the way raylibAPL and how it's dynamic when it's calling the quad NA, it was difficult for him to figure out how to convert to pointers. But he did figure it out in the end. And then another issue that I noticed with I/O is input lag. When a player would put in an input, it wasn't always registered. And I believe that this is due to the thread issue that I was talking about earlier, where depending on where the program was in its execution, because it takes so long to execute in the render loop, sometimes the input is not registered because it's past the detection for input, and then it clears the inputs at the end of the loop and then checks for inputs again. So that can be a bit of a difficult thing to manage. And me and Brian had a lot of talk about that because we had a lot of talk about the threading issue. And we are looking into other thread options as well. So why should you care about all this stuff? Well, raylib isn't just useful for games. It could be used for anything that needs graphics. It's possible to make just a simple GUI app, as I mentioned earlier, with the raylib RayGUI, and this is fully working in raylibAPL, and it has many different customizations. And we also, of course, we do have simpler GUI options available to us in Dyalog APL, such as EWC and QuadWC and all those things. But raylibAPL is still technically an option. You can see here that this is, I think this is just a configuration tool written using RayGUI. But you can see here it's quite customizable, and there's a lot of different options available to you. And as I mentioned earlier, I think VR is a really interesting use case for it. I know that there are some companies that use VR for their internal training. For instance, I have a friend in Waterloo who implemented a training software using virtual reality to train crane operators. And this could all be done in APL. And you could have a VR headset essentially displaying a 3D APL game in virtual reality. And another thing is, raylibAPL also brings cross-platform game making in APL, as it works on all platforms that Dyalog works on. And I believe one of the first, so as I said earlier, one of the first 3D games written in APL was Stormwinds, I believe. And I don't think that worked on other platforms other than Windows. If I remember correctly, it used some Windows library to do it. So this, with raylibAPL, it works on all platforms. So in conclusion, raylibAPL is definitely viable for graphics-heavy apps and not just games. And this summer, I was able to build a good 2D game, FlappyBird, and then a 3D ArrayLab prototype with model loading, collisions, and dialogue scaffolding. And then this summer, I learned quite a bit about GPU and main thread constraints, and that asset loading needs a lot of care. Physics and input handling is difficult to do in a single thread without performance impacts. And then, of course, many bugs were squashed in raylibAPL. And then I think I did make quite a few reports to support at Dyalog, and I noticed that I think all of my reports, for the most part, have been fixed in the latest 20.0 beta release. And raylibAPL is almost ready for 1.0, according to Brian. However, there are still some things that I would like to see in it before it reaches 1.0, namely better Unicode support, better integration with my workflow in the Dyalog IDE, because Brian does not use the Dyalog IDE. That's sort of something that I've been working on. And I would also like to investigate the threading issues and look into a better physics model. And then other than that, I would also like to acknowledge all of the work that Brian has put into raylibAPL and the generous support that I received from Dyalog over this summer. And I also look forward to working with Dyalog in the future. So, any questions? Brandon.
You talk about doing several rewrites.
Yeah.
And I'm curious about your experience of how APL has facilitated your sort of exploration of new ideas and what you're supposed to do, like new rewrites, new architectures you were playing with.
Well, my initial brute force attempt was just using, a loop over all of the different combinations. But that was obviously not a very array-oriented solution. So I kept rewriting it to be more around vectors and more around, parallel SIMD operations and stuff like that. Does that answer your question?
Yeah, I'm just wondering if you found it very, APL made it easier to sort of.
Yeah, I think
sketch out
it did. It did, most definitely. I found that the looping was very difficult to get my head around. I always prefer when I'm writing something in APL to be doing everything in sort of an array format. And I think it's just more efficient to do it that way anyways. So,
Is your
yeah.
code available?
It will be available. It will be available. I have to figure out getting the models because GitHub doesn't like huge gigabyte models. So yeah.
Have you tried something with a billiard?
The what?
Billiard? Billiard?
A billiard pool. Pool. No, I haven't. No. Maybe that's a future. Yeah. Yeah. Max.
Aside from your Titan CLI, another interesting peripheral work out of this is a CI setup for Dyalog.
Yeah.
And I think your peripheral work kind of highlights this tooling issue in Dyalog.
Yeah. Well, I did. I should mention for raylibAPL, I did actually make a CI CD for raylibAPL to build I built everything because of course we had a C library that we needed to build. So I built that automatically every time that Brian wanted to make a release, and then I also made it such that the Titan package would be automatically built every time Brian made a commit to the main branch of the repository, which was very helpful. And then there was even a way to release it onto the titan.dev repository. So yeah.
Yeah, perhaps that could be externalized for other projects.
It is, yeah, it is available on the raylibAPL GitHub repository, so you can kind of take a look at some of that there.
It's making a separate repo like Titan CLI.
Yeah, there is a Titan CLI repository on my GitHub, yeah.
But for CI.
Yeah, for CI, I can do that, yeah. Yeah, perfect. See no other questions.
Cool. Thank you.
Thank you.